Category 5, or Cat5 cable, is a type of twisted pair copper cable primarily used for computer networks. Its design features 4 individual pairs of copper wires twisted together. This twisting is crucial because it reduces electromagnetic interference, ensuring a cleaner and more reliable signal transmission. The primary application for Cat5 cables lies in establishing Ethernet connections within both home and office networks, facilitating communication between computers, routers, and other network devices. While Cat5 cable is predominantly employed for computer networks, its versatility extends to various other applications. One such application is in telephone systems, where Cat5 can be used to connect phones to a central switch or a phone system transmitting voice signals. Security systems represent another area where Cat5 cable finds utility. It can be used to connect security cameras, motion sensors, and other security devices to a central monitoring system, enabling the transmission of data and video feeds. Video surveillance systems also commonly utilize Cat5 cable to connect cameras to a recording device or network, facilitating the transmission of video footage for monitoring and storage. Furthermore, point-of-sale systems, commonly found in retail environments, may employ Cat5 cable to connect cash registers, barcode scanners, and other POS devices to a central server or network, enabling data transfer and transaction processing. When considering the price per foot of Cat5 cable, several factors influence the cost. These factors include the brand, the quality of materials used in construction, and the length of the cable being purchased. As a general estimate, the price of Cat5 cable typically falls within certain ranges. For bulk spools, which typically contain 1,000 feet or more of cable, the price per foot can range from approximately 5 cents to 10 cents. This option is often more economical for large-scale installations or projects where a significant amount of cable is required. Alternatively, pre-terminated cables, which come in lengths ranging from 10 to 100 feet, tend to be priced higher per foot, typically ranging from 10 cents to 25 cents. These cables are pre-cut and fitted with RJ45 connectors, making them convenient for smaller installations or when specific cable lengths are needed. In addition to the above, there are several additional considerations to keep in mind. Firstly, Category I category cables, such as Cat5e and Cat6, offer faster data transfer speeds compared to standard Cat5 cable. However, these higher category cables also come at a higher cost. Secondly, shielding. Shielded cables provide enhanced protection against electromagnetic interference, making them suitable for environments with high levels of electrical noise. However, shielded cables are typically bulkier and more expensive than unshielded cables. Thirdly, length. Longer cables generally cost more due to the increased material and manufacturing requirements. When selecting Cat5 cable, it's essential to consider the specific requirements of the application and environment. For standard Ethernet connections in home or office networks, Cat5 cable provides a cost-effective and reliable solution. However, for applications requiring higher data transfer speeds or enhanced protection against interference, Cat5e or Cat6 cables may be more appropriate. Ultimately, the choice of cable type should be based on a careful evaluation of performance requirements, environmental conditions, and budget constraints. Category 5 cable finds use beyond just computers. It serves as a versatile option for very low bandwidth data and voice applications. While initially designed for computer networks, its adaptability allows it to be utilized in security systems for transmitting data from sensors to control panels, telephone systems connecting handsets to main lines, and even video surveillance setups for short-range camera feeds. The key to its broader use lies in understanding its limitations. It's best suited for applications that don't demand very high data rates. Cost estimates for Category 5 cable will vary depending on several factors, including the vendor, quantity purchased, and whether the cable is shielded or unshielded. Buying in bulk usually reduces the price per foot significantly. Shielded cable, which provides better protection against electromagnetic interference, will generally cost more than unshielded. Location also matters, as regional price differences can exist due to shipping costs and local market conditions. The best practice involves obtaining multiple quotes from different suppliers before making a purchase to ensure you receive the most competitive price. To recap, Category 5 cable is a twisted pair copper cable primarily designed for computer networks but capable of serving in other applications. It is not exclusively for computers, as it can be found in telephone systems, security setups, and video surveillance, albeit for low bandwidth needs. Pricing is variable, influenced by vendor, quantity, and shielding, making comparison shopping essential to secure a reasonable rate per foot. Understanding these aspects helps in selecting the appropriate cable for specific needs and budget. The design of Category 5 cable, with its twisted pairs of copper wires, is not accidental. The twisting is a specific engineering choice to mitigate electromagnetic interference. Each pair of wires is twisted around each other, and these pairs are also twisted together. This configuration helps to cancel out noise and crosstalk between the wires. Crosstalk happens when the signals in one wire bleed into another, corrupting the data. The twisting effectively balances the electromagnetic fields, reducing this interference. This makes Category 5 cable more reliable for data transmission, especially over longer distances. When we mention its use in computer networks, what are we referring to exactly? It serves as the backbone for Ethernet connections. Ethernet is a standard protocol for local area networks, or LAN, which allows devices like computers, printers, and servers to communicate. Category 5 cable provides the physical connection that carries the Ethernet signal. It's the wire that plugs into your computer's network card and runs to a router or switch, enabling you to access the internet or other devices on your local network. The RJ45 connector at the end of the Cat5 cable is the standard interface for these Ethernet connections. What about the alternatives to Category 5 cable? As technology advances, newer and improved cables have been developed. Category 5E, or Enhanced Category 5, is an improved version of Cat5 that offers better performance, particularly in reducing crosstalk. Category 6 cable is another step up, providing even higher bandwidth and better performance than Cat5e. It is designed to support faster data transfer rates, making it suitable for more demanding network applications. Category 6R, or Augmented Category 6, offers even greater bandwidth and improved performance over longer distances. These newer cables are often used in commercial settings or where high-speed networking is required. Fiber optic cables represent another alternative. Fiber cables use light to transmit data, offering significantly higher bandwidth and longer transmission distances compared to copper cables like Cat5. Fiber optic cables are typically used in large networks, data centers, or for connecting buildings where very high speeds are needed. When considering cable choices, factors like the required bandwidth, transmission distance, and budget play a crucial role. For simple home networks or less demanding applications, Cat5 or Cat5e may still suffice. However, for businesses or environments with higher bandwidth needs, Category 6 or fiber optic cables might be more appropriate. It's worth noting that cable standards continue to evolve, so staying informed about the latest technologies is important when designing or upgrading a network. Now let's consider cable installation. Proper installation is essential for ensuring optimal performance and reliability. Care should be taken to avoid sharp bends or kinks in the cable, as these can damage the wires and degrade the signal quality. Cables should be properly supported and secured to prevent them from being pulled or strained. Cable ties or Velcro straps can be used to bundle and manage cables neatly. When running cables through walls or ceilings, it is important to use appropriate conduits or cable management systems to protect the cables from damage and comply with building codes. Testing the cables after installation is also a crucial step. Cable testers can be used to verify that the wires are properly connected and that the cable is performing to specifications. These testers can identify common problems such as shorts, opens, or cross wires. Proper testing can help to ensure that the network will function reliably and that any issues are identified and corrected before they cause problems. What about safety? When working with electrical cables, safety should always be a top priority. Before installing or working on any network cabling, it is important to disconnect the power to the equipment and circuits involved. Avoid working with cables in wet or damp conditions, as this can increase the risk of electric shock. Use insulated tools when working with cables to protect against electrical hazards. Follow all applicable safety codes and regulations when installing network cabling. If you are not comfortable working with electrical cables, it is best to hire a qualified electrician or network technician to perform the work. What about future trends? As technology continues to advance, the demand for higher bandwidth and faster data transfer speeds will continue to grow. This will likely lead to the development of even newer and more advanced cable technologies. Wireless networking technologies, such as Wi-Fi, are also becoming increasingly popular. While wireless networks offer convenience and flexibility, they could also be subject to interference and security risks. Wired networks, using cables like Cat5, still offer a more reliable and secure connection for many applications. As a result, it is likely that both wired and wireless networks will continue to coexist for the foreseeable future. Understanding the characteristics, applications, and limitations of different cable types is essential for designing and maintaining effective networks. Whether you are setting up a home network or managing a large enterprise network, choosing the right cable and installing it properly can make a significant difference in performance and reliability.